Okay, so today Math Model Semester 2 lesson is 1.61, the study of graphs of quadratic functions. So we're going to look at some parabolas. Okay, so let's talk about the key terms. One of the key terms we got is x-intercept. And x-intercept is just the point where the graph of a function crosses or touches the x-axis. Let's go ahead and write that up. All right, so the x-intercept, it's a point where the graph of a function crosses and touches the x-axis. A function can have 0, 1, 2, or even more x-intercepts. It just really depends on what the graph look like. Now, here's an important word, the vertex of a parabola. The vertex, when you think about that, it's just a point. And in this case, the vertex is just a point on the parabola where it changes directions. So let's go ahead on and write that up, and then we're going to draw a picture to make it make a little bit more sense. Okay, so like I said, the vertex of the parabola is just the point where it changes direction. So if I was to go ahead and draw a quick sample of what a parabola looks like, you have your y-axis as well as the x-axis. And let's say I have this parabola here that happens to go through this point right here. I'm just going to call it negative 2, 0. Really and truly, it could be negative 3, 0, whatever. The only thing that's important is that it's on the left side of the origin and it does not go up or down, so it's at 0. And then this point over here, I'm gonna just call 2, 0. All right. In this case, the x-intercepts is gonna be negative 2, 0 and 2, 0 because that's where it crosses the x-axis. And then the vertex is just where it shifts. So if I was to put a point right here, and I really don't know what that point is, I'm just going to make up a number just for the sake of argument. And I'm going to call this one 0, I don't know, negative 2. It could very well be negative 3 or negative 4. It don't matter. I'm just trying to prove my point. The vertex is just the point where this graph right here, it came down, and then right there, boom, hit the vertex, and then it goes back up again. Okay? Now, your main idea is that all graphs of quadratic functions are parabolas that open either up or down. On our previous example, ours happened to open upward. We're going to fill in the blanks to complete the list. Vertex of a parabola, these are some characteristics of it. It's the point where the curve of the parabola makes its sharpest turn. All right. It makes the center of the parabola, your vertex, always locates the center. The parabola's line of symmetry passes through it. So symmetry, that's a familiar word right there. Symmetry just kind of is like a mirror or like a reflection. It's the same on both sides of the vertex. All right, and it's also the halfway point between the parabola's two x-intercepts. That's our new word that we just learned today, x-intercepts, once again. Okay, so now we at our next set of direction, and it says label the vertex and the x-intercepts. Now, what I want you to remember is that the vertex is the sharpest point, so as best I can, that point right there is going to be your vertex. So let's label it. Excuse my handwriting. That's your vertex for that parabola that opens upward. And it happens to have the location for negative 4. Always good to label your points. And then over here, let's pick another color. In blue, these 2 points right here, that's your x-intercept. So I'm going to write that kind of big and then draw an arrow. So that's one of them. And that's the other one. And this one here has the coordinate 2, 0. And over here, we are at 6, 0. And what you're going to see on the next page is asking you about the vertex of this graph we just labeled. The vertex here is actually going to be your lowest point. This is the lowest point of the graph that happens to open upward. Now, over here on our next example, our vertex happens to be the highest point. It's the opposite because this one is opening downward. So our vertex is our highest point. And I'm jumping the gun a little bit, but that's okay. That point right there is going to be your vertex. And it has the coordinates 0, 5. All right. And just as a reminder, that point happens to be your y-intercept. Ooh, look at that. Extra vocabulary word. Just throwing it in there. Okay, and these are your x-intercepts. I'll write it down here. X-intercepts. And I'm going to put an arrow just in case. Make sure we know x-intercepts right there. and it happens to have the coordinates 2, 0 and negative 2, 0. Whoop, fix my negative sign because it don't look like one to me. Okay, so from the last page, and I hate how this was cut off, the vertex is going to be the lowest point. Let's pick another color. That one didn't show up. It's going to be the lowest point for the parabola that opens up, but counter is going to be the highest point when the parabola opens down. So our next main idea is that the x-coordinate of the vertex is the average of the x-coordinates of the x-intercepts. Sounds confusing, but let's explain. So it says how to find the vertex of a parabola. Step 1, find the average of the x-coordinate of the x-intercepts. So all they talking about, let me show you right here. Boom, 2, boom, 4. So we know how to find the average. That's like finding your average when you're doing your grade. You add the 2 up and divide them by 2, since all you got is 2. Alright, so when we add 2 and 4 and divide it by 2, we get 6 over 2, which is 3. And so that is the x-coordinate of my vertex. It's 3. Now, step 2 says plug the x value into the parabola equation to find y. So everywhere I see an x, I'm going to put a 3. So now I'm just going to start plugging things in because I need to figure out what that y coordinate is here in order to get a complete point. So everywhere I see an x, I'm plugging in a 3. So 3 squared minus 6. Whoops, I don't know what happened there. 6 times 3 plus 8. Okay, you put that in your calculator just how you see it. When you get done, you'll get y equals a negative 1. So then my vertex has the point 3, negative 1, and just like that, boom, you're done. It said write the results from step 1 and step 2 as an ordered pair. We just did that right here. That's all that meant. Okay, so what I did was put the equation in the graph so you could kind of see what it's going to look like. So we got x squared, press y equal and put it in there. Now I press graph. Boom. Okay, and so we see that the point right there, 3, negative 1, happens to be our lowest point inside of our graph. And if you want to verify, you can look at the table. So press second in graph to get to the table. And you see at the point 2, 0, it passes through that point. It's a little blurry, but okay, there we go. 2, 0 passes through there. 4, 0, it passes through there. So I got my x-intercepts. But then look right here. 3, negative 1. That's our vertex right there. See there? We did good. Alright, so the next main idea is that the y-coordinate of any x-intercept has to be 0. So it says how to find the x-intercepts of a parabola. Given our example, y equals x squared minus 6x plus 8. Now that happens to be the same one that we have right above it. Let's see, I'm going to show you. You see this graph right, that equation? If you look, whoops, excuse me, Miss Gable, being Miss Gable, making mistakes. All right, but if you look right here, that's the same. Oh, I wanted to highlight. Goodness, it's the same exact equation right there. So we move on. So it says how to find the x-intercepts. The first step that we want to do is start with an equation in standard form where y is equal to ax squared plus bx plus c. And we got lucky, because we got something right over here in standard form. So then it says substitute a 0 in for y. Let's do step 2. Okay, so I put a 0 where you got a y. That was step 2. And then it says factor the trinomial. So this part right here gets a little bit tricky because everything depends on this 8 and the coefficient in front of this x squared, which is 1. So there are 2 numbers that you can add together. Since that's a 1, you just really focus on the 8. But there are 2 numbers that you can add together, and it equals negative 6. And yet those same 2 numbers, when you multiply them, got to equal 8. And in this case, those numbers are, and I'm going to set it up. This is about to look familiar. You'll have an x here and an x there, because x times x is x squared. And then over here on the other side, we're going to put a minus 4 and a positive No, that's not positive. There's a minus. And a minus 2. All right. Now, if you want to factor that out and you need some help, just let me know. But those are going to be your factor of your trinomial. So then step 4 says use the product rule to solve for x. So here we go. Step 4. We're going to do x minus 4 equals 0. And then, and then we're going to do x minus 2 equals 0. Well, in this case, you need to add 4 on both sides. So you get x is 4. And then over here, you need to add 2 on both sides. So we get x is 2. And now we know what our intercepts are. So we says write the results from step 4 as an order pair x. So right here we have 4, 0, and 2, 0. Whoops, 2, 0. Okay, so our next main idea is that if A is the x coordinate of an x-intercept, then x minus A is a factor of the quadratic equation. And we see that right here, where x minus 4 was a factor of the equation. So it says number 5, use the given steps to complete the example. How to use the x-intercepts to write the equation of a parabola. So all we know is that the x-intercepts are 2, 0 and 4, 0. Or 4, 0 and 2, 0. Okay, so step 1 from the last page just told us to start with the x coordinates of the x-intercepts. And I went ahead and wrote everything up here at the top so we have it. But the x-intercepts are 2, 0 and 4, 0. So step 2 says write them as factors x minus a using step 1 for a. So here we go. If we were to rewrite it as x minus a, then here we're going to have x minus 2 and x minus 4 equals 0. And it says use FOIL to multiply the factors. I'm okay with using FOIL. Hope you are too. If not, there's another method that I can show you that may be a little bit more familiar. But we can go ahead on and use FOIL. X times x is my first. So that's x squared. The outer x times a negative 4 is negative 4x. My inner, negative 2 times x, negative 2x. And my last, negative 2 times negative 4, positive 8. And this still equals 0. So then I put it all together, and I got x squared minus 6x plus 8 could equal y, because it can be graphed. All right. So that's our equation. We just keep getting the same thing over and over again, and that's good. Okay, if you're not getting the same thing, just let me know and I'll help you out. So our next main idea is that the vertex form of a quadratic equation is y equals a times x minus h squared plus k, where h and k are going to be your vertex. All right. So in summary, we're going to use the given steps to complete the example. The equation is the vertex form of the equation for a parabola. So what you see underlined right there in blue, it is the vertex form of the equation for a parabola. So the word that goes right here on this line is vertex. Now it's vertex form because when you see it, you can easily identify what the vertex is. In this equation, the x value of the vertex is given by h. And the y value of the vertex is given by k. So we're going to use the given steps to complete the example. It says how to use the vertex and another point to write the equation for a parabola. Label the vertex form and standard form of the equation. So step 1 says start with the coordinates of the vertex hk and another point x, which is what we already have here. Okay, substitute the terms into the equation. I'm going to do what I was advised to do. Give me 1 second. So what you see to the right, h equals 0, k equals 2, x equals 1, and y equals 3. So when you do this over here, it kind of gives you a heads up as to the things that you need to plug in. So we're going to take our equation, y equals a times x minus h in parentheses squared plus k. Now it's going to become a little bit easier to plug some things in. Watch and see. I just went ahead and plugged in the values that I have. Now step 3 says solve for a. So that's going to be, I hope, easy. But 3 is going to equal a. 1 minus 0 is just 1. And 1 squared is just 1. So it's just going to be a. Whoops, I did it again. I wanted to put... Don't put that there. Put a 2 because that's what it tells you that it equals right there. So it's just going to be a plus 2. And so the last step when solving for a, subtract 2 on both sides. So a is going to equal 1. So step 4 says substitute a, h, and k into the equation y equals ax minus h squared plus k. So here's what it's going to look like. We have y equals 1 times x minus 0 squared plus k, which is 2. And when we simplify that, we just get x squared plus 2. Now, here's the thing. There is an error on this problem. And if you run into that error, not the one that we just did, this is really going to be your final answer, which you see. Whoops, that was not smart. This is really going to be your final answer, which you see that goes to this part right here. But inside of Apex, I saw a mistake. And so make sure that you use what I have written here. Don't look at what Apex have. If you get confused, of course, let me know. That's why I'm here to help you. Hey, we almost done. It says fill in the blanks to complete the rule. Using the quadratic formula to find the vertex. For the parabola defined by this function, defined by the function ax squared plus bx plus c, which is your standard form, the coordinate of its vertex are what you have here. Okay, that should be coordinates on that line, but it's really not enough space, so I'm going to just draw an arrow. But that's what goes there. So the coordinates, you can find the vertex by doing negative b, or the opposite of b, divided by 2a for x, and it's going to be the function of negative b, or the opposite of b, over 2a, times those two together. Let's do a practice one. We'll get to the practice in just a second. Here's your main idea. You can use the quadratic formula to find the vertex of a parabola and identify how many x-intercepts it has. So step 9 says use the given steps to complete the example. How to find the vertex of a parabola. Now, we are given y equals 3x squared plus 12x plus 1. We want to first identify a and b in the function. Here goes. That's our a and b. In this case, a is 3 and b is 12. So that's our step 1. And then it says find the x value of the vertex. So we're going to do the opposite of whatever b is divided by 2a. So I'm just going to plug it in. Opposite of 12, divided by 2 times 3. Okay? And so that's going to be negative 12 over 6, which is just a negative 2. Okay? Negative 2. Okay. And that's actually the x-coordinate in our vertex. So then the next thing it says, step 3, substitute the results from step 2 into the parabola equation and solve for y. All that means is wherever I see an x, I'm going to put a negative 2. So 3 times negative 2 squared plus 12 times negative 2 plus 1. That comes from right up here, our given equation. So y is going to equal, and you can put that whole thing inside your calculator just as it is. If you got a question, let me know and I'll tell you how I got it. But y should equal a negative 11. So our vertex for this one is negative 2, negative 11. Okay, so what you see is I just put the equation that we was given into the calculator. And I want you to see what it looks like when you graph it. So that's what my graph looks like. It's kind of hard to see, but don't worry about that. What I really want you to focus in on is the vertex, which is off the graph because this one is a 10 by 10. So I'm going to zoom out a little bit and see if it shows it. So it's going to be way more narrow, but that point negative 211 is now able to be seen. And if you want to verify that you got it right, you can always look at the table to make sure that it's a point on the graph. And it just so happened to pop up first, negative 2, negative 11. See there? Good job. Okay, and just as a reminder, we looked at discriminants before, and remember discriminant is just that part that's left underneath the quadratic equation. So x equals negative b plus or minus square, b squared minus 4ac all over 2a. Okay, so b squared minus 4ac was our discriminant. Now, what you need to remember is that if it is negative, then we have 0 real roots. It's going to never touch the x-axis. If the discriminant is 0, then it's going to have 1 real root, which just means that it touches but never crosses the x-axis. Okay, and if it's positive, you got 2 real roots and it crosses the x-axis at 2 points. All right. So now here's the thing that I tell you all the time. You know Miss Gable loves you very much, and I am here to help you if you need help with anything. I encourage you to do the practice problems, okay? And if you got a question on those practice problems, let me know, because once again, I'm here for you. All right. Have a nice day. Bye-bye.